and welcome back to Build Propulsion Lab at Devoxx France 2024, coming to you live from Paris. And I have two guests with me, Nicolas and Guillaume. Welcome, both from Docker, both from Docker Compose team.
Yeah.
And you might know Docker Compose as a way of just combining running containers for your local environment. But apparently there is a lot going on and stuff that is very, very relevant to the theme of the Build Propulsion Lab, which is developer productivity. So let's dig into it. What's between Docker Compose, developer productivity, and what's new in this arena?
Yeah, we've been working for maybe 1 year now within the Compose team to try to focus to the development in a loop. So Compose is not just about defining somehow complex application that involve multiple containers that need to run in a specific order. We really want to embrace the fact that as a developer, you are doing change and you need your application to be updated. And based on telemetry, we noticed that a bunch of people are using Docker Compose stop, Docker Compose build, Docker Compose up again and again and again all day long, every time they do something in their code. So we introduced a new feature, was maybe a year ago, but unfortunately not well covered by blog posts and all the happy voice we would expect. But it's called watch. That's a Compose up flag that you can use, as there is also a dedicated command for this purpose. The idea is that as part of your Compose file, we introduce a new development section. You already have the build, the deploy, and you have a new development section where you can define triggers that happen every time some file is updated on your source code. And you can associate with actions that can be just rebuild the Docker image and restart the application accordingly. Managing dependencies is if you are, let's say, working on some backend code and you need your front end to be updated because maybe you changed the roots of your API. And there's also an option to just synchronize file with your container. So we cover two patterns here. One is, let's say, compiled software and those with interpreted code. So as a, let's say, Node.js or Python developer or Ruby developer, you will rely on the sync feature, which means that you will just get your code, sync it into the container, so it's always running the latest version of your code. That's something people used to do with just a bind mount, which may not be as efficient as expected, and especially require that everything is local. With this sync approach, we can cover remote engines, maybe cloud-based development environment, and also we somehow abstract away this concept of being able to synchronize files that not necessarily a bind mount, that can rely on mutagen, for example, to get fast synchronization, or any other implementation details that we manage. So from a user point of view, you just say, when I'm in development mode, my source folder needs to be synced in my container, and the rest of my Compose definition is really to run this container in production mode. So we separate the concepts. And the other category is compiled language, let's say Java, because we are at Devoxx and lots of Java attendees here, but also applies to Go or everything that needs a compiler to create the binary. And then just being able to say, as files get updated, we'll get automatically your image being rebuilt, which suppose that you optimize a bit your Docker file so that you benefit from cache. So you don't spend hours getting everything from scratch. But once you did this job, you just change code and get the rebuild, refresh, and your application is up to date. You don't have to get into the terminal, restart manually, and so on. It just happened for you. And so, yeah, that's just...
So effectively,
no more distraction.
Effectively, you got the continuous mode, right,
Exactly.
which is supported from Gradle, for example. Every time your code is changed and your file is saved, it will compile it automatically and then do something with it. In our case, it will actually build a Docker image and then update the Docker container, like create a new Docker container, should I say. And then you will have your application up to date every time you change something without the need to restart.
Exactly, and
this is very cool.
Yeah, the point is really to try to get best of both worlds at some point. If your local tool is also able to do some sort of partial recompilation, reusing cache and so on, and not starting just by compiling everything from your source code, you can really have something really fast. And by discussing with people during the Devoxx conference, some of them were using Spring Boot with Tomcat and so on. They're saying, I don't even need to leave my IDE anymore.
Exactly.
Just write code, wait a few seconds, and then my Tomcat restart. I see the logs, and hop, I get my web app restarted with the latest version.
Yeah, that's exactly the idea of this continuous mode, right? We're just
Exactly.
writing code and everything is updated as we type, compiled, redeployed, restarted, and this is...
And you really don't need to bother about the details of what's happening behind, just wait a few seconds.
This is very cool.
That's
Cool. It is.
And,
it is.
and you can choose the strategy. Imagine you have another application. You want to sync when you change your source code, but you want to rebuild your image when you change your package JSON file. So you can have, for the same services, different strategy depending on the type of file that
has changed.
Yeah,
Yep.
exactly.
No, this is very cool.
A very common issue where people just switch branch, and they had already bindmonths to get this same experience. And they don't understand why the application doesn't work, because as part of switching branches, some dependencies were updated, but the live reload of their stack doesn't manage dependencies to suddenly disappear. So here we can really have those two patterns to say there is some changes can be dynamic, some need actual rebuild.
We might only need to bring new files and that's all, and sometimes we actually need to redeploy. Yep. And we can, depending on the files changed, we can decide which is the right strategy.
Exactly. So you define this once by just rules, and then you forget about it.
This is very cool. All right. And what was the other one that you wanted to mention?
So the other one is something that we will show for the first time here at Devoxx France.
No, it's exciting.
There is a common issue for people using Compose during development process, and that need to go to Kubernetes world at the end for production. And we try different kind of solution.
Many, right?
Yeah. There is some existing tool like Compose with a K that try to do that. But the adoption is not really great because as we analyze everything, because the program is still there, because we don't give the user the ability to customize the output he wants, because there is as much as flavor of Kubernetes deployment possibility that Kubernetes developer.
Yes.
In fact, so what we try to achieve here is give the possibility with a simple command line to get a Compose file as an input and produce using transformer, which are basically Docker images, so you can share that very easily across your company. To get that Compose file, apply the transformation, and generate your Kubernetes resources in YAML. So currently we have example to manage basic declaration of resources like services deployment and so on. But we also provide by default a customized configuration, an overlay for Docker desktop, so you can easily deploy what you have done inside the Docker desktop Kubernetes cluster. Just we manage for you the way that you will store your data and what local storage will be used and stuff like that. And we also have some Helm examples, so you can generate Helm template, and we generate and populate the value.yaml file for you. That's cool. But how you can use that to match your need?
That was my question. You mentioned there is a problem. There are so many flavors of doing the same thing. So how do you overcome it?
So we give us by default something that will work with Docker Desktop easily and in a quick way, and then you can just create a new transformer based on what we have done, and that will copy for you all the. It's basically using Go template, so it will copy all the Go template for you, and then you will be able to add new file that you want to generate, remove file that you don't need on your side, add for the customized part, you can add extra overlay, For Helm, you can define what value you want to inject inside your value.yaml file and blah, blah, blah. And then you just repackage that as a Docker image and you just run compose, bridge, convert, and then you pass your new image and you will get the transformation matching your need.
This is great. And then you can take this Docker image and you can share it with your colleagues in your normal Docker registry.
And what we hope also is that the community will embrace that view to say, hey, we want to provide you some GKE configuration, transformer, stuff for AWS and Azure, Alibaba. Yeah. And you can also imagine having, you can change the transformer. So you can apply one transformation, then apply another one. So what we can do, for example, it's say, hey, I want to deploy on, GKE, and I want also to use ingress. And I have a transformer specifically that will create all my ingress configuration regarding my input. So that's it. So we will need some help from the community to make
write all those kind of stuff of transformers, make them chainable and interchangeable.
For specific use cases, you can have individual transformers that focus on, let's say, I don't know, integrate with Vault for secret management, and just focus on this very specific use case.
So
add to the canonical templates we generate.
So it will take the compose file, do something very small, and then pass it on to do the rest of it.
Yep. And if you're not happy with it, it's really easy to just take the template, tweak it for your needs, or maybe write really your own if you have a very specific way to do it, because everybody is writing Kubernetes, you know.
Exactly.
And maybe you even did something internally.
Yep.
Writing code with the API and the SDK, and that still works because we can just package it inside a transformer Docker image. We can run it as part of the other templates. So just combine them all together.
What we can say also that we know that Compose doesn't have all the stuff you may need for your Kubernetes deployments. But for people who knows, there is some extension attributes you can add inside the Compose configuration. And what you can do is say, hey, I want to add this extra configuration that won't be interpreted by Compose when you run locally, but that the templating engine will be able to say, hey, I want to inject that also inside my kube configuration at the end. So, for example, if you have, I think that could be the case for the, all the traffic routing.
We recently introduced in the Compose 5 format the ability to define the application level protocol as not just TCP or UDP, but maybe HTTP, gRPC, HTTPS. And that's something that doesn't make any change to Compose, but once you get this additional metadata, the transformer can do better job generating the right ingress or gateway API or anything else that is required in Kubernetes. So pretty easy to just add more metadata by the developers inside Compose because it's just a few lines.
Even the Compose itself doesn't use it, but it will be a single source of truth for those declarations that then the chain of transformers will generate the right output for each and every part in my stack.
Exactly.
Brilliant. Yeah, I love it. That sounds great. That sounds very, very useful and goes right into the productivity that we spoke about. Hopefully, fingers crossed, the community will pick it up. Now it's all in the hands of people just, getting this snowball rolling. And in some point of time, obviously, if that picks up, everything will come with those transformers out of the box. So it will be very, very natural to have them, to share them, to use them. And of course, fingers crossed that that's exactly what's going to happen.
We hope.
Yeah.
And if you want to give it a try, just ping Guillaume on Twitter.
Sure.
Yeah,
that's fine.
No,
honestly, you can do it.
But on top of that, it's a good question. How do we learn more? Where do we go to get started?
We will share our slide deck after the conference, and there will be a QR code and a link that will bring you to a form where you can apply to be notified when that will be ready. It's just a matter of days or weeks, honestly.
That's exciting.
Everything is.
Maybe we can add this to the notes.
Yeah,
so,
maybe,
so
okay,
obviously the easiest thing to do, just go to Gradle Twitter and you will see a reply by Guillaume with the link
Okay, exactly.
to where
Perfect.
do you need to sign up.
Perfect.
Here we go.
Let's do
There we
that.
go. Folks, thank you very much
Thank
for
you.
sharing.
You're
This
welcome.
is really exciting and very interesting. And for you folks at home, stay tuned for more of those gems that come live here at the Build Propulsion Lab at Devoxx France 2024. Thank you very much, and bye-bye.